The deep universe is not only a physical system of stars, galaxies, and cosmic forces, it is also a profound source of philosophical reflection about existence, order, and the nature of reality. When scientists study the universe at its largest scales, they often encounter patterns that raise questions far beyond physics. These patterns suggest that the cosmos is governed by underlying principles that connect mathematics, matter, time, and consciousness in ways that continue to inspire both scientific investigation and philosophical thought. One of the most striking patterns in the universe is the existence of order emerging from apparent chaos. Galaxies are scattered across space in vast networks known as the cosmic web. Instead of being randomly distributed, they form filaments, clusters, and enormous voids stretching across hundreds of millions of light years. These structures resemble branching networks similar to patterns seen in natural systems on Earth, such as river basins, lightning paths, and even neural networks in the brain. This recurring geometry suggests that simple physical laws, such as gravity and motion, can produce remarkably complex structures over time. Another deep pattern is the mathematical nature of the universe. Physical laws that describe gravity, electromagnetism, and quantum behavior can be expressed precisely through mathematical equations. From the motion of planets to the formation of atoms, mathematical relationships appear to govern the behavior of reality itself. This observation has long fascinated philosophers and scientists because it raises a profound question: why should the universe obey mathematical principles at all? Some thinkers argue that mathematics is simply a language humans use to describe patterns, while others believe mathematics may be embedded within the structure of reality itself. Time is another dimension where physics and philosophy intersect. Modern theories describe time as part of a four-dimensional structure called spacetime, where space and time are interwoven rather than separate. Gravity can bend spacetime, and motion can alter the rate at which time passes. These discoveries challenge the intuitive human perception of time as a constant, flowing stream. Instead, time may behave more like a dimension through which events are arranged, raising philosophical questions about whether the past, present, and future all exist simultaneously within the fabric of the universe. The deep universe also highlights the theme of impermanence. Stars are born from clouds of gas, shine for millions or billions of years, and eventually die, sometimes exploding in dramatic supernova events. These stellar explosions scatter heavy elements across space, elements that later become part of planets and living organisms. In this sense, the atoms in the human body were once forged inside ancient stars. This cosmic recycling suggests a continuity between the universe and life itself, reinforcing the philosophical idea that humans are not separate from the cosmos, but rather expressions of its ongoing evolution. Another pattern observed in the universe is the balance between simplicity and complexity. The fundamental laws of physics appear surprisingly simple, yet they produce astonishingly intricate systems, from spiral galaxies to ecosystems and intelligent life. This contrast raises philosophical questions about emergence, how complex structures and behaviors arise from simple underlying rules. Just as simple mathematical formulas can generate complex fractal patterns, the universe seems capable of generating layers of complexity from a relatively small set of fundamental principles. The scale of the universe also introduces profound existential questions. Observations suggest that there are hundreds of billions of galaxies, each containing billions of stars and potentially countless planets. This immense scale challenges human perspectives about importance and uniqueness. At the same time, it raises questions about life elsewhere in the cosmos and whether consciousness may arise wherever conditions allow it. Philosophically, the deep universe often inspires reflection about meaning and understanding. Humans evolved on a small planet orbiting an ordinary star, yet the human mind has developed the ability to investigate phenomena billions of light years away. Through telescopes, mathematics, and scientific reasoning, we have begun to uncover patterns that shape the entire cosmos. This capacity for comprehension suggests that intelligence is one of the universe's ways of becoming aware of itself. The deep universe therefore reveals more than distant galaxies and cosmic forces. It reveals patterns that connect science with philosophy, order emerging from chaos, mathematics underlying physical law, complexity arising from simplicity, and consciousness exploring the universe that produced it. Each discovery expands our knowledge, but it also deepens the mystery of why the universe exists and why its patterns are understandable at all.